Next, the world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded 1 million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope.
A massive traveler has slipped into our solar system, a stranger from another star. And for the first time, the James Webb Space Telescope has captured it in breathtaking detail. But what exactly is this object? A comet, an asteroid, or something far more mysterious, a messenger carrying secrets from a distant world? Astronomers call it 3I Atlas, only the third interstellar object humanity has ever seen. Unlike comets that loop back around the sun, Atlas is on a hyperbolic path, which means it's just passing through. Once it's gone forever. The discovery already had scientists buzzing, but when Webb turned its golden mirrors toward this cosmic visitor, what it revealed shocked even the experts. Earlier interstellar objects like Oumuamua and Borisov left us with more questions than answers. One looked like a stretched-out shard, the other fizzled like a small comet, but both were frustratingly blurry in telescopes. Atlas is different. Webb's high-resolution infrared view delivered a sharp, clear image, the first real portrait of an interstellar traveler. For once, scientists could actually see the surface, the scars, even the faint clouds surrounding it. And that's when things started getting bizarre. The image showed shimmering reflective patches right next to dark, jagged scars. Ice glistening like a comet, rock fractured like an asteroid. Atlas didn't fit neatly into either category. This hybrid nature suggests it was born in the frozen outer reaches of some distant star system, then violently hurled into space. Part comet, part asteroid, and completely alien. But the surface was only the beginning. Surrounding Atlas, Webb spotted a faint halo of gas and dust, a coma. That shouldn't have been possible for a traveler that's drifted through the frozen void for millions of years. The coma means Atlas still carries volatile ices, preserved since the day it left its home system. In other words, Atlas is a time capsule from another star, a frozen messenger holding clues untouched by billions of years of solar radiation. But inside that halo was an even greater shock. Webb's spectrograph split the light and revealed Atlas's chemical fingerprint. It showed familiar compounds like water ice, but also exotic organics, never before seen in comets from our system. Some scientists believe these alien molecules could be the universal building blocks of life, scattered across the galaxy. The discovery fuels speculation that interstellar objects like Atlas might not just be wanderers, they could be couriers, delivering the ingredients for biology itself. But size matters too, and Atlas is unlike anything we've seen before. Unlike Oumuamua, which was barely a few hundred meters long, Atlas spans several kilometers. It's a giant. Its survival means it endured a violent ejection, perhaps a gravitational slingshot, past a massive planet or even a close brush with its star, and still remained intact. If one huge object can cross interstellar space and reach us, how many more might be drifting silently through the galaxy right now? Webb's precision revealed something strange about Atlas's motion. It doesn't spin smoothly like most asteroids or comets. Instead, it tumbles chaotically, as if it's been knocked around countless times. This irregular spin may be the scar of its ejection, or the result of ancient collisions. Every twist, every scar, tells the story of a solar system we may never see, except through this wandering survivor. But the most important revelation isn't just about science, it's about us. Atlas proves the galaxy is alive with motion, with objects constantly migrating from star to star. It means our solar system isn't isolated, it's part of a cosmic network where debris, ice, and even organic molecules are exchanged. Some scientists even wonder if life on Earth could have been seeded by interstellar visitors like this in the distant past. And in the future, humanity might not just watch these objects. We could intercept them, land probes on them, even bring back samples. But for now, Atlas is a fleeting visitor, here for only a moment before disappearing forever. Webb's capture of Atlas isn't just a photo. It's proof that interstellar space is not empty, but alive with travelers carrying stories from distant worlds. This one object is part comet, part part asteroid, and part mystery. It may hold alien chemistry, it may carry the seeds of life, but one thing is certain, it will never return. And if Atlas is just one, how many more wanderers are out there right now, slipping silently between the stars, waiting for us to notice? When Oumuamua passed by in 2017, scientists scrambled to make sense of it. It looked like a stretched-out shard, maybe even a metallic needle, and it had an odd acceleration no one could explain. Some even speculated it wasn't natural at all. But the truth is, our telescopes at the time just weren't sharp enough to give us a clear view. We were left guessing. Then came Borisov in 2019. That one looked more like a typical comet, trailing gas and dust. But even then, the resolution wasn't enough to see fine details. Again, questions piled up, answers didn't. But Atlas is the breakthrough. When Webb captured its first image, astronomers were stunned. For the first time, we had a clear, high-resolution portrait of an interstellar object. Not just a blurry dot, not just a streak of light, but an actual visible body, with structure, surface features, and surrounding material. And what Webb revealed was stranger than anyone expected. On the surface, Atlas seemed confused about its own identity. Its reflective patches glistened like ice, hinting at frozen water or exotic ices sublimating in the sunlight. But right next to those bright glints were dark, jagged scars, the hallmark of rocky asteroids. Was it a comet? Was it an asteroid? The truth was, it looked like both. A hybrid? And hybrids don't really exist in our system. Objects here are usually one thing or the other. Icy comets from the Kuiper belt, rocky asteroids from the inner belt. But Atlas had elements of both at once. This suggested a violent past. Maybe it was born in the frozen outer reaches of a distant star system, then knocked inward, fractured, reshaped, and finally flung into interstellar space. A wanderer scarred by countless battles, still carrying the signature of the world it once called home. But the biggest shock wasn't the surface, it was the halo. Surrounding Atlas's Webb's instruments picked up a faint coma of gas and dust. A cloud, glowing in infrared light. This shouldn't have been possible. Atlas has been drifting through deep space for millions, maybe even billions of years. Exposed to freezing temperatures, blasted by cosmic rays, every volatile element should have boiled off long ago. Yet here it was, still carrying a halo, like a comet fresh from the Kuiper belt. The only explanation: Atlas must have been preserved in near-perfect conditions, a cosmic freezer protecting it since the day it left its home system. That makes it more than a rock. It makes it a time capsule, carrying chemistry from another star system, chemistry untouched since the dawn of its creation. Then Webb did something even more powerful. It split the light from Atlas, using its spectrograph, reading the object's chemical fingerprint. And what it revealed was extraordinary. Water ice, yes. Carbon compounds, yes. But there was more complex organics, structures we've never detected in comets from our own solar system. Strange hydrocarbons, unusual signatures that didn't line up with anything we've catalogued here. Some scientists immediately made the connection. If interstellar objects carry alien organics, then they might also carry the seeds of life. Could Atlas or objects like it have delivered the very building blocks of biology to young worlds? It's a theory known as panspermia, the idea that life's ingredients spread from star system to star system on drifting rocks and icy bodies. And Atlas might be our first clear proof that it happens. Another revelation came when scientists measured Atlas's size. Unlike Oumuamua, which was maybe 200 to 400 meters long, or Borisov, which was about a kilometer, Atlas is enormous. Several kilometers across. That makes it a giant interstellar visitor. Massive enough to survive a violent ejection from its home star system without being completely shattered. To reach us, it likely endured slingshots past massive planets, close brushes with its star, and then millions of years adrift in the dark. And yet, here it is, still intact. If something this large can cross the gulf between stars, how many more giants might be passing unnoticed through our galaxy every single day? But Webb didn't just capture Atlas's surface. It also revealed how the object moves, and the motion was strange. Instead of spinning smoothly, like most asteroids or comets, Atlas tumbles chaotically. Imagine a brick flipping end over end in zero gravity. No rhythm, no regular spin, just a messy, unpredictable roll that tells scientists something important. Atlas has had a violent history. Maybe it collided with other objects in its home system. Maybe it was torn apart and reassembled. Whatever the cause, that chaotic tumble is the scar of ancient trauma, a reminder that this traveler carries a story written in impacts and collisions. All of this leads to a profound realization. Atlas proves that interstellar space is not empty. It's alive with motion, with debris, with travelers that cross unimaginable distances. Some are fragments of shattered worlds. Some are icy relics carrying chemistry from alien stars. And some, just maybe, are couriers of life itself. For scientists, this changes everything. If Atlas can reach us, then countless others can too. Our solar system may constantly be brushed by material from distant stars. And Earth itself. It may not just be a planet in isolation. Next, the world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded 1 million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope. NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. The first real image of 3I Atlas captured by the James Webb Space Telescope is more than just another milestone in observational astronomy. It marks a pivotal moment in our attempt to understand the mysterious wanderers that occasionally pass through our solar system from interstellar space. Until now, these objects, 3IA Atlas being only the third recognized interstellar visitor, were fleeting blips that telescopes struggled to observe in detail before they receded back into the dark. What Webb has delivered is an unprecedented high-resolution image that offers clarity, not just visually, but scientifically. It is as if the veil over a cosmic stranger has finally been lifted, revealing features that fuel both awe and inquiry. Before we start, smash the like and subscribe buttons for more updates. The image itself radiates with Webb's characteristic sharpness, showing Atlas in a way that was simply impossible with previous technology. Earlier interstellar objects like 1 Umawan-Mu and 2I Borisov were constrained by the limited instruments available at the time. Observations provided basic clues about their trajectories and surface compositions, but their true physical character remained ambiguous. With 3I Atlas, Webb's infrared capabilities have peeled away layers of mystery. The telescope's position beyond Earth's atmosphere means no atmospheric distortion. Its instruments can capture faint glimmers and subtle contrasts that ground-based observatories could never manage. The result is an image where Atlas is not a dim streak against a filter, but a resolvable body with surface features, spectral details, and a visible coma of outgassing particles. One of the most striking revelations from Webb's image is the texture of 3I Atlas's surface. For years, theorists debated whether interstellar objects would resemble the icy comets of our solar system or take on the rocky profiles of asteroids. The captured image shows a surface that glimmers with reflective patches, suggesting volatile ices that are actively sublimating under solar influence. At the same time, darker scars and irregular shapes hint at impacts and fractures accumulated during its long journey through deep space. This duality, part comet, part asteroid, suggests Atlas might be a hybrid, carrying the building blocks of both rocky and icy origins. Such a body could only be born in the outer reaches of a distant star system, later ejected into interstellar space by gravitational encounters. The coma visible in the image, a faint but distinct halo of gas and dust surrounding the object, transforms Atlas from a mere rocky body into an active traveler. This halo is not as prominent as those surrounding large comets in our solar system, yet its presence speaks volumes. It means that even after crossing the void between stars, Atlas has preserved volatile compounds that are now being released under the warming touch of our Sun. This is crucial because it gives astronomers a pristine sample of interstellar material, unaltered by billions of years of solar radiation or planetary encounters. In a sense, Atlas is a time capsule from another star system holding unprocessed remnants of its original birthplace. Webb's instruments did not stop at imaging. Its spectrographs recorded the unique chemical signature of 3Y Atlas, breaking the light reflected and emitted by the body into telltale bands. Early analysis already points to compounds both familiar and alien. Water ice seems abundant, but intermixed with exotic organic molecules rarely seen in solar system comets. These molecules could hold clues to how chemistry unfolds in environments vastly different from our own. Even more compelling is the possibility that such compounds are universal seeds of prebiotic chemistry, capable of seeding life when delivered to hospitable worlds. If Atlas carries such molecules, it strengthens the case that interstellar bodies are messengers of cosmic chemistry, scattering the ingredients of life across the galaxy. The sheer size of Atlas, as revealed by Webb's imaging, adds another layer of fascination. Unlike Oumuamua, which was a slender, elongated fragment only a few hundred meters long, or Boris, a relatively small comet-like body, Atlas measures several kilometers. This makes it more akin to a full-fledged comet nucleus than a fragment. The scale suggests it survived a violent ejection from its parent system intact, a process that must have involved dramatic gravitational interactions with giant planets or passing stars. Seeing such a large object travel the gulf between stars underscores how dynamic planetary systems can be. If one large object can escape, countless others likely do as well, turning interstellar space into a quiet highway of wandering debris. The orbit traced for 3I Atlas confirms its interstellar origin beyond doubt. Webb's precise measurements of its trajectory show a hyperbolic path curving through our solar system only once before departing forever. Unlike comets bound to the Sun's gravity, Atlas is not returning. It is simply passing by, and Webb's image has frozen that passage in unprecedented detail. Knowing this adds a sense of poignancy to the discovery. This is a fleeting visitor we will never see again. Yet, it also emphasizes the importance of the Webb telescope in capturing such ephemeral moments. Without its capabilities, Atlas might have slipped by with only minimal observation, just another blurred entry in astronomical catalogues. Instead, it now stands as a case study in the birth, evolution, and survival of interstellar wanderers. Astronomers are already drawing comparisons between Atlas and the interstellar objects that came before it. Where Oumuamua's strange elongated shape sparked theories of artificial origin, Atlas appears more conventional, though still exotic in detail. Where Borisov behaved like a typical comet, Atlas presents a hybrid personality. These contrasts are invaluable because they highlight the diversity of objects flung from other star systems. No two interstellar visitors may ever be the same, reflecting the infinite variety of planetary system architectures across the galaxy. Webb's image proves that each arrival is a unique chance to peer into another world's history. Beyond astronomy, the implications of Webb's image ripple outward into other scientific fields. Planetary formation theories must now account for the fact that entire kilometer-scale objects can be expelled and travel interstellar distances intact. Astrobiology gains new data on how life's chemical precursors might be disseminated across vast expanses. Cosmochemistry, the study of the elements and compounds that shape worlds, gains a rare laboratory sample preserved from beyond our solar cradle. Even philosophy finds resonance here as humanity contemplates the reality that matter from unknown stars is brushing past us, tangible and observable in real time. The visual impact of Webb's image should not be understated either. For the public, the photograph of 3I Atlas is an invitation into the profound. Unlike theoretical models or blurry images, this is a real sharp portrait of an interstellar traveler glowing faintly against a tapestry of stars. It makes the vastness of the galaxy suddenly intimate. Somewhere out there, a planetary system gave birth to this object. Somewhere, forces tore it away, sending it on a trajectory that happened to intersect our small solar neighborhood. To look at the image is to see a story etched in rock and ice. A journey that spans millions of years and uncountable distances. Webb's achievement also energizes the conversation about how humanity might interact with such objects in the future. Today, we observe them from afar, content with the light they reflect. But as imaging improves and the catalogue of interstellar visitors grows, the notion of sending probes becomes more tangible. A mission to intercept and study such a body up close could reveal even more about their structure and composition. Bridging the gap between distant observation and direct exploration, the Webb image is a spark for those ambitions, demonstrating what is possible when the most advanced telescope humanity has ever built turns its gaze outward. For scientists working on Webb, this moment validates decades of effort. The telescope was designed not only to peer back in time to the early universe, but also to examine objects within our own galactic neighborhood with unrivaled detail. Capturing Atlas blends those missions beautifully, a local observation with cosmic implications. Every pixel in the image is hard-earned, the product of precision engineering, flawless deployment, and patient alignment. To see it pay off with such a discovery is a triumph for the entire scientific community. As researchers continue to analyze the data pouring in from Webb, more layers of 3 Atlas's story will come to light. Already models of its thermal properties, rotation, and surface erosion are being refined. Every aspect adds to a growing portrait of an interstellar visitor, not just as a curiosity, but as a critical data point in understanding the galaxy's restless dynamics. The image Webb revealed is not a conclusion, but a beginning, a foundation upon which years of study will be built. The wonder of 3 Atlas is not only in its uniqueness, but in what it represents. It is proof that interstellar space is not empty, but alive with travelers, each carrying a story from a different star. Webb's image crystallizes that reality in a way words alone cannot.